Yes. So, hello everyone. I am Yogesh, and I will be your TA, which is teaching assistant. So, I will help you out. So, it's a 8 week course. So, I will help you out to solve those assignments. Basically, the assignment which has given by professors. So, both of the professors. So, there are two professors, right? I mean, you already know them. So, one professor deal with the theory stuff, which is mathematical part, and the other part, the other professor, which deals with the practical part, where you can apply those theories and all those things. So, and so the course name is Robotics and Controls, Theory and Practice. So the theory part will be handled by Professor Suva Karan, and the practice part will be handled by Professor Felix. So I will, so I will So what I will, so this session will be held every week this time only. Okay. And what I will do in this session is like I will solve some problems, which is not the same as which was given, but something on the similar lines so that you get to know like how to solve those problems. And if you have any doubts like what books to refer, what anything like if you haven't understand any particular concept or any particular slide, so I can help you out with that also. Okay, so uh, I will just share my screen so that you can see what all. I think, yeah, so I will share my entire screen. I think my screen is visible, yeah. So so what you can, so I will so I'm Yogesh. I'm a PhD scholar at IIT Bombay. Okay. So I myself do have gone through these courses. So based on the courses, I myself do this mostly research part. So I already gone through the I already gone through the theory part, but now I'm using that theory to do research mostly on the robotics part. But my other background is biomechanics part, which I will let you know in the coming weeks. So, first of all, what uh, since this is an interactive session, you can also interact with me. So you can unmute yourself at any time, or what you can do is you can use this chat box. Okay, so I think we have this chat box here, so you can type it any questions or anything which you haven't understand, or any problem or any specific problem you haven't gone through, haven't able to understand or like that. Okay, and there's nothing hard and fast rule for language. You can ask me in Hindi also. So मुझे हिंदी अच्छे से आती है. So if you have any particular question कि वो समझ नहीं आया, so you can always ask me in Hindi also. Okay, but I will try to teach in English. Okay, so since this is me, so I want to know more about you. So can you please type in the chat box like what background are you from? Like have you done engineering or economics? If you are from engineering background, so which branch are you from? Electrical, mechanical? You can type it in the chat box, and because I am from mechanical, by the way. So yeah, so otherwise, is from mechanical, robotics, and automation. Okay, so you have done a robotics and automation diploma, and you're doing. Okay, so you are a diploma, or you are a BTech, or you are a engineering. Same. Okay, you have done this. Okay, okay. Shreyas is also from mechanical engineering, BTech in mechanical ongoing. Last sem of diploma is going on. Okay, so mostly mechanical. Anyone from electrical? Okay, some Vivek Kumar is from MTech. Anyone from electrical, yeah, electrical electronics? So we have one industrial engineering ongoing. Okay, okay. And B, okay, Shashank is from B, Samir is from mechanical. Okay, Sangnam here. Okay, so most, I think, so anyone from like have done their have done their engineering and are doing something on are currently in the industrial side, or are not on the are not in the academic background right now. I mean, are their industries. So Nand Kumar. So mostly we have youngsters. Okay, that's great. Oh, BTech in chemical engineering. Okay, Nand Kumar. Okay, so I was working in Siemens for last 7 years. Okay, Shashank Nambiar was working, but now you Shashank has okay. Shashank is electrical engineer, but I was working in Siemens for last 5 years. Now I want to pivot to robotics. Okay, okay. That's great, Shashank. So let me tell you my background. So I've done my bachelor's from Bhilai Institute of Technology. It's in Chhattisgarh, and after that I've done my master's from IIT Bhubaneswar, and after that I worked in L&T for 1 year, and after working in L&T for 1 year, uh, I've left that job and I've started pursuing my PhD. This is my fourth year of PhD. I will tell you a little bit about myself as the week progresses. Okay. So yeah, so Shashank, yeah, it's good to know. Now I want to pivot to robotics. Yeah, it's good. Great. So I will tell you the most of the course basically deals with the mathematical part. So it's a mathematical intensive course. Okay. So because since I mean it's an NPTEL thing, okay, so we don't have any practicals to show. But I will so since this is the first week, I will show you some student projects. I mean these are not that project, but these projects which I have gone through, there are multiple projects at IIT Bombay which students do. But yeah, Ajmer Rana, BSc in non-medical, BSc, okay, BSc in non-medical working, BSc non-medical working in electricity board. Okay, okay, working in electricity. Okay, okay, so BSc in non-medical background, and you are working in electricity board. Yeah, that's great, Ajmer. Yeah, so we have one guy from industry also. That's great, Ajmer. Okay, so yeah, so what I will do is like, I mean, since I mean, I will go through those assignments also. This is your interface, right? You got this week one, so you have to submit assignments. So there is always a deadline. So you see, there is something called a due date. Okay, so for week zero, here are your lectures basically. So you have to go through these lectures. Okay, so please go through this lecture. And there are, I mean, if you somehow skip some lecture and you have some little bit time, so what you can do is like there are some slides also. Okay, so these slides will be useful when you go to when you want to do the revision part. Okay, okay. If you have forgot some concept, please go. So these are the slides which you can access. And in week one there are 1, 2, 3, 4, 5. So there are like 5 lectures, and I think all are in the range of half an hour. Okay, so so please go through this lecture, and based on this lecture we have this quizzes which you need to answer. Okay, so these are the quizzes. So you see, you just need to, it's a multiple choice question. So there is only one correct answer. Okay, so please uh, fill this assignment and submit the assignment before a due date. So the due date for assignment one is like 25 to it's February 5. Okay, and similarly the due date for assignment two is if you have any question, yeah, you can unmute yourself and you can ask me anytime. Or what you can do is you can use the chat box, right? Okay, I think I will regularly check the chat box. Okay, okay, there's no question. So yeah, so these are the week two assignments. So I will not solve exactly the same problem, but similar to the same problem I will solve. So that you get to know like how to solve this kind of a problem. So yeah, so please remember the due date. So there are for week one and week two, both of the due date is ending at 5th of February. Okay. So please submit the assignment before 5th of February. And there are other things which I wanted to tell you. So the thing is like if you have any questions, right? Like if you have any questions about let's say about the books, what you want to refer. Then there is something called apart from books, there are like if you have any specific question on a particular slide, or if you think that this assignment question is wrong or the options are wrong, so and you wanted to communicate to us, right? So how you can do it? So there is something called I think Q&A. So you need to go through Q&A, and you will be directed to this Google discussion section session. And what you can do is like you can use this. I think there are some problems. So this, okay, so there are, okay, I have a question in the lecture. Okay, so you see that there are already some guys are asking some problems. Okay, so there is composite erosion. So yeah, you say Mohit have asked, I have a question about what is happening in video 2.2. So we had said and shown you the formula to find the vector component. Okay, so you have this yeah, you have this groups which you can where you can ask problems. Okay, so please utilize this group. I think I don't know who will be answering to this groups. There are other TAs. So like you see, there's this TA called Gaurav Bharadwaj who have already answered these questions. Okay, so you say, okay, so please use this discussion portal effectively, and this session which I am giving you, it will be recorded and it will be uploaded in this problem solving recordings. Okay, so you will so if you go to this recording, it will open this Google Sheet, and you get to access the YouTube links, the links which I will share in this session. So this session recording will be given here. Okay, so please be mindful of that. And I think, yeah, so that is some information which I wanted to convey. And I think if anybody have any problem, you can chat in. And so what I will do is like I won't take. So it is given that it can take 2 hours, but I won't take much time. So I will try to complete within 45 minutes. Okay. So since already 15 minutes have passed, so I will take half an hour more. And since this is an introductory session, I won't take a long. So I will solve some problems so that you get an idea like how to solve those problems. So mostly the problems, if you see in the first assignment one, you see most of the problems are like multiple choice, and there are some numerical problem like this one. And there's I think yeah, so this is a problem on similar lines. And then there is a rotation matrix, and you need to find out so these problems, I think you can easily solve it. So if a is given, then the magnitude, so magnitude of a vector you can easily find out. So these are like elementary based problems, but I will solve one problem so that you get to know like how to do those things. Yeah, so I think let's start with some introductory lectures. So like, so welcome to yeah, I think I am audible. And I think so if, yeah, I think yeah, here's me. So welcome to week one problem solving session, and we'll start this session with showing you some sort of robotics project which is done by the bachelor student here at IIT Bombay. And I think I will start, and so that you get a motivation like how they have done it. So how the student, based on the theory, how they have performed those how they have come up with some projects. So this is not an IIT Bombay student project, but it's a it's a deep learning robot which you see. So there's this lady, I think it's from RTWA Germany. So she's a PhD student, and she's teaching the robot to play something like table tennis. You see, so 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 they have trained it. How she trained it? She moved that manipulator. So I will show you. Yeah. So like that. So uh, somebody is hitting the ball from the other side, and the ball is coming to that pad, and she's teaching how to play. Okay. After, and due to a deep learning model, they have taught it well, and so yeah, and you see, he's doing all by himself. So basically, it's like a two. It's not a 2 degree. I think it's a 6 degree of freedom robot. There is a not 6 degree. I think one, two. Yeah. So basically, 4 degree of freedom uh, manipulator is there. So so this was developed by I think I met the professor in charge during one of the conference. I think not remember his name, but yeah. So this was a project. I think it was in RTASW in Aachen. Not yeah, RTASW Germany, Aachen. So that is the application part, which that this is the motivation behind learning the robotics. And there's this sorry, I think, so I think there's this KUKA robot thing. So KUKA is a robot. It's basically a 6 degree of freedom robot. You see here, what they are doing is like they are teaching this 6 degree of KUKA robot to pick this part. Okay, so there is this point one, point two, picking this palette, and okay, so there's point two, point three, and it's like, and there's this is some kind of a wall is there, and so it's clicking that button, and that robot is taking that position as points, different points, and you see, so there are different points, and there's this obstruction solver. So the robot needs to pick that object, and without colliding with that obstruction, he need to follow this path made by these intermediate points. This is how. Uh, so this is some kind of a trajectory planning, which we will teach you in, I think, in week 3 or week 4. Okay. So this is a KUKA robot. I think it's yeah, it's a Germany-based robot, one of the popular robot. And I think yeah. So this is so this is a project which I was talking about. Uh, uh, this is some kind of a crab robot, which was developed by an IIT Bombay BTech student. So you see, there are these four. These are called, I think, miniature. These are called, I think, square motors. Square. These are called. These are rectangular based motors which act like a crab legs. And I think I will. You see, like they are using this Arduino Mega control this robots. Okay. Yeah. And I think there is, I think, one more project. I think this is the other project which I think am I audible? Yeah, I think am I. If anybody have any question, please do ask me. Yeah, I think you can please type in. Yeah, I think my sharing the screen. So yeah, where was I? Yeah. Hmm. So there was this. So it's a 2 degree of freedom manipulator. You can see here, and there are these two servo motors, and I think there are three servo motors. So there is one, P. So this is for rotary motion, and there is these two motors, and they are like writing something like a or a arrow kind of thing. Okay, so they feeded that trajectory to this all three different servo motors. So we will teach you how to write those the software part, the crux, not the software part, but basically the coding part. So the theory will help you how to write those coding part or how to understand. Now you can write those code using Chat GPTs also. But you all know that this AI agent can also do. They also give this errorless results, right? So you need to know like what they are giving, and if they are giving Is it right or not? Okay. So so that is what we need to teach you, and I have prepared some slides. So I will go through that. So I will start with some kind of a introduction to a sensors. So so this is not a part of your syllabus, but this is for your introduction only, like how the sensor work, and there are some questions which I will solve. So there are like I prepared some 4 questions which you will find it helpful. So I will also share these slides with you. Okay. So let's start the introduction. So can anybody tell me like what sensor is? Like you can type it in the chat box. Like what the first thing comes into your mind like when you see a sensor? Like yeah, you can give me any definition. Like what do you mean by sensor? You can write it in Hindi also. It's fine. Yeah, any idea? Wanna tell what do you mean by sensors? I mean, what the first thing comes into your mind like if I give you like okay, this is sensor. And how sensor is different from actuators or motors. Anybody? Anybody wanna wanna answer that question? An object that can sense change in environment and given data to controller. Object that can sense changes in environment. Yeah, you are right. That can sense changes in the environment. You are right, Kumar. And given data to controller. Yeah, so it gave data to controller. Yeah, you are right. It did data to controller, not the actuators. Right. Convert physical data into electrical signal. Yeah, yeah, the way yeah, that's really that's the answer which I was looking for. But yeah, Nand, you are also right. So there's this physical thing which is changing, and we need to convert that physical thing into electrical signals. So that is basically what a sensor is. So yeah, so basically devices that receive a non-electrical signal, which is called stimulus, which is basically a physical change, and it respond them with an electrical signal. So so this is called sensors, okay? And devices that receive this non-electrical signal. So let's say if I am pushing some object, right, and I want to measure how much force I am applying to it, okay? So this force is a physical thing, right? This is a non-electrical thing. How to how to sense that thing, right? So what we can do is like we can have this some kind of a capacitor thing has to be there so that if we push something, then there will be some deformation to something like let's say I think this is how strain gauges work, but I will show you. I think, so let's say this is your object and you are pushing with your hand, and there is a sensor called something called a load cell. Okay, I will show you how load cell works. Basically, load cell is basically it's a Wheatstone bridge. Okay, so it's basically has a resistance. Okay, I don't know if you remember Wheatstone bridge. This is how it look like, right? And there are these R1, R2, R3, R3. There are 4 resistance. Okay, and if you know from elementary, so this resistance is equal to rho L by A, right? Rho is the resistivity, A is the area of cross section. So if you change the length of a resistor, let's say a wire, then the resistance will change, right? So if you push something, there is this sensor, there is this device is called Wheatstone bridge is there, and due to that force, this will deform, and due to the deformation, due to the change in the length, the resistance will change. And when resistance change, you can convert that into electrical or a current or a voltage, right? So basically, this is how you sense things and this is how you do things. So basically, there are different types of stimulus. So there is a mechanical stimulus, there is a thermal change in the environment, there is a chemical change in the environment, there is a magnetical change in the environment. And all this physical thing, we need to convert them into electrical thing. So how to do that? There are these electrical quantities. These electrical quantities are called thing. So there is this electrical quantity like resistance, inductance, capacitance, voltage, and current. So these are the electrical quantities which we need to sense. If somehow we can measure this, I mean we can measure this, but if somehow you due to this disturbance we can measure how R or how L is changing, we can develop any sensor. So let's say for a force sensor, we are using strain gauges. The sensor is called strain gauges. And what they do is like due to the resistance voltage change. So due to that resistance and a voltage change. So let's say if I'm pushing, if I'm pushing more, length will be the deformation of that resistance will be more, and due to that deformation, the resistance will be more. And if the resistance more, then the voltage will be very low. According to that, it can give you some change in voltage, and that voltage can be mapped to a, let's say, a force. Okay. And there is this temperature sensor. They use something called RTD thermocouple. So there also we measure change in resistance, change in voltages. There is a humidity dielectric where we measure change in capacitance. Then there is a AC voltage. So there is a position and displacement which is called LVDT. I think if you have heard, there is a light incident LDR or photodiode, so which measure resistance current. So these are sensors which will be helpful when we you develop something like robots, right? So this is basically the simple the concept of what sensors are, and yeah, I think yeah. So there is this something like so there is this activity which not activity but an exercise which I have to which I will which I always do with my students. So you have this iPhone, okay? Can anybody tell me like how many sensors which you can tell this iPhone consists of? Like, can you name them? I want the names, like what kind of sensors and not what they do, but can you name the sensors? What an iPhone have? Okay, yeah, we will go to questions with yeah, yeah. Anybody? How many? Okay, okay. Otherwise, user screen this for something. So, yeah, otherwise you are right. So can anybody tell me like how many sensors or what kind of sensors do an iPhone have? You can unmute yourself and you can talk to me in Hindi also. It's fine. Sensor like gyrometer, yeah, the way you're right. Yeah, gyrometer, right? Yeah, the way you're right. Gyrometer is one of them, which measure the angular velocity. So I think if you open your what none? Yeah, proximity sensor. Yeah, of course. So you're right. If you and the camera. Touch sensor, yeah, touch sensor is one of them. Camera is, yeah, of course, camera is the other sense. Camera is the sensor which can sense any object is coming or not. So camera is one of them. Light sensor, yeah, which is light sensors are there. So if you proximity sensors, of course, proximity sensor is one of them because based on the proximity, your mobile get automatically lit when you uh, have your hand nearby, something like that. There's a proximity sensors and all that. So all of them are right. So I will tell you how many sensors your mobile. I mean, there might be more. Okay, so this is not the final list, but yeah. So there are like touch sensor, touch screen. The touch screen is a sensor when you use your finger and you touch something, you are creating something like a stimulus, and that is sensed by your mind. There is an image sensor, which is basically your camera, and then there is a fingerprint sensor, right? That will sense the fingerprint, that will sense those lines, and they will those are the biometric sensors, right? And then there is a microphone which measure your, I mean, yeah, which record your voice, right? So not record, but that transmit also. And there are other sensors like proximity sensor, ambient line sensor. The ambient line sensor is something like it's like the sensor like senses the what is the brightness nearby. Okay, and if you know, then there's an option called automatic brightness. Like if you open your mobile and in a dark room and as compared to in a very lit room, the brightness will automatically change. So that's called ambient line sensor. Then there is accelerometer which measures the accelerations, and there's the gyrometer which measures the velocity, angular velocities, and accelerometer is basically measure the acceleration. So if you in a train, so you can download some app called there are different apps like. if you're moving in a, let's say, a Vande Bharat, you wanted to measure what is the speed. So you can have an app and you can always measure what is the speed. So there's a gyrometer, there is a barometer. Barometer measures the pressures, okay? And then there is a magnetometer, temperature sensor, pedometer. Pedometer is, I don't know if you, so can anyone tell me what pedometer is? I think anybody, we have some- what pedometer? Pedometer, and there is a Hall sensor. Hall sensor, I think you might know. Hall sensor is basically it's like a proximity sensor only. But pedometer, like pedometer, you should know. I mean, yeah, most of them pedometer, yeah, it's a step counter. Yeah, you are right. So basically, how many steps you have gone. So basically, it measure the small vibrations. So like if you vibrate this something like this, then you will get the how many steps you have gone through it. So these are some sensors which I wanted to tell you. Then there are sensors like linear position sensors. Then so this sensor are also been classified into like it measure positions or linear. Then there are sensors called a proximity sensor. Then there are sensors called measure the angular position. Then there are sensors called load cells. So this load cell sensor will measure the how much loading. I don't go into the I won't go into the principle behind it because it will take time. But yeah, so I will take 15 more minutes, and I have to complete also. So then there is something called IMU. IMU is inertial measurement unit. I think if you have seen those actors, I mean, if you have seen those high action movies, if you see those the Hollywood movies where they wear this something called this suit. This is called a motion capture suits. Okay, and most of these people wear this suit. Most of these movie stars wear this suit, and they have this kind of a biomechanical model of a human body can be drawn on a motion capture software, and we can use this or we can manipulate this line diagram according to our needs. So that's how they do those I mean those the graphics of those Hollywood movie stars. So this is called so what they do is like they have these bands. You see those bands have this something called IMUs. Okay, so these are called inertial measurement units. This IMU itself has three sensors, which is accelerometer, which measure acceleration in gravity, and then there is a gyroscope, which measure how much angular velocity that link. So if you wear this IMU, let's say in your limb, if you have a, I think I will. So yeah, so you see this there's this guy is wearing this. So those yellow or the reddish thing you see, those are an IMU, which IMU consists of gyroscope, accelerometer, and magnetometer. So what they do is like they always in real time giving these values, which is accelerometer, gyroscope, and magnetometer, which is magnetometer is basically measure the magnetic field. Okay, so it basically measure the direction. Let's say Earth have like north and south pole, right? Based on the based on that north and south pole, that magnetometer will tell the direction with respect to your global coordinate system. Global coordinates basically how you are oriented. Are you oriented north or south? So this is called magnetometer. Then there is a gyroscope which measures the how fast your limb is moving or something like that. So this is basically the IMU, and this is how it IMU works. IMU convert that value into yaw is basically some kind of a position. Based on different limb position, we will build this models. Okay, so this is something different sensor. And then there is something called lidar sensor, which is I think most of this autonomous vehicle use it. Okay, this is called light detection and ranging software. So basically most of this autonomous vehicle, okay, so when they drive it, they need to do some kind of something called a localization, where they need to see how they are positioned with respect to other cars and how they are positioned with respect to something called with a global map. Okay, so this lidar itself has these three different sensor, which is called IMU sensor, GPS, and laser sensor. So what they do is like, let's say this is your plane, they will give laser, they will emit this laser rays to every directions, and if some obstruction is there, what they will do, that laser will bounce back and come to its receivers. And from that, the car knows that there is something beside or something proximate. So it's kind of a proximity sensor. Then there is something called IMU. IMU I already know. This IMU will tell you like how it is oriented. Let's say, I think that I'll just give you a small example and we'll move on to the question. So let's say this is something like your car is there, okay, and this is your road and right, and you have this IMU, okay. The car has to know how it is being oriented. Like let's say if a car is like this or the car is like this IMU will also tell you orientation. Orientation is basically the degree, how much degree is has been oriented with respect to the road. So if a car doesn't know how it is being oriented, they can go like this also, they can go like this also, right? So the car orientation basically it's like how angle it is tilted. Okay, so from that the IMU will help you, and then there is a GPS. So GPS will tell you like where the road is going and where your starting point and where your end point. So these are the three different sensors, which is basically called lidar. Okay, I think Google used to use this Google cars. I don't know if Tesla is using that. Tesla is using something different, but yeah, we can debate it, and you can also Google that stuff. Okay, so there are different sensors called load cell which measure loads, and there is a sensor called angular position where gyroscope, tachometers, stroboscope. So these are different sensors, and there is this proximity sensor. There are ultrasonic, inductive sensor, temperature sensor. So these are different sensors which you want to know or might know, but this is something which I've prepared it. Now move on to the questions. So the first week session is all about yeah, this is all about the inverse kind of. So the question which was given here is based on the introduction, the first lecture, which is basically the introduction lecture, where the different types of yeah, different types of robots, different degree of freedoms. Yeah, I mean the coordinate transformation and all those things, and the different coordinate frames, how to transform one frame to another frame, right? So based on this, I've made some questions. So let's start with the question, and I think there are two, three, four question, and we will wrap it up. Yeah, I think yeah. So yeah, so this is the question number one, and let's see question number, right? So consider the following coordinate transformation matrix. Okay, so this is your transformation matrix, right? The transformation matrix is 4 cross 4. Okay, yeah, 4 cross 4, and these are represented by vectors N, O, A, and P vectors. Which which of the following is not true? Okay, so first let's see what the question tells you, what the question is asking about. So there is a transformation. Where was the pointer? Yeah, I think yeah. So this is your transformation matrix, and if you know this 3 cross 3, this is your rotation matrix, right? And this is your position matrix. Okay. So if you don't know what I am talking about, please go through the lectures. Okay. And they want to know this cross product n cross o. This n is basically this n. This n vector is basically this n x I n y j, and their cross product is basically they're asking, and which of the following is not true? Okay, A, B, C, D. So can anyone tell me like what would be the answer? A, B, C, D. Anybody? I think I will check. Okay. Yeah, Nand Kumar. Yeah. Can this PPT be shared? Yeah, yeah, it will be shared. Uh, Janhav, Janhavi, Janvi, yeah, Janhavi. Yeah. We will share this PPT also. Okay, so please. So there's this. I will again tell you like where you can find this PPT. So there's this problem solving bar is there. You can just need to open it, and that this window will open, and this window will take you to this Google Sheet. So currently I'm not posted it, but you will find a folder here. I will make one. after having session. Okay. So anybody? So basically, it's a rotation matrix. Okay, and this rotation matrix, if you see this rotation matrix, all are orthonormals to each other, right? Say orthonormal means so this is your axis, right? This is something like x, this is y, and this is z, right? And this is and this is a transformation matrix. Okay, and this transformation matrix will something look like this. This is something like I don't know, but this is like n o and let's say a. Okay, and they wanted to know like how this, so all these three vectors o a, yeah, all these three vectors are perpendicular to each other, right? And they all know, right? So if let's say n is perpendicular to o and o is perpendicular to a, right? All these things are perpendicular, but they need to also, so the cross product of two perpendicular line or a vector, let's say o or a, will gives you the other vector. That is what the orthonormal definition, orthonormal, and yeah, that is what the orthonormal matrix definition was, right? But here you see n cross a, so which of them following is not true? So like let's say all are giving the right, the all are giving the same value, all are not giving the same value, but all are giving, if two different vectors are being multiplied, they are giving the third vector, right? But which of them is not, which of them is wrong? That is what the question is, right? So this is something which you need to know. So if this is following something like a right hand rule, right hand thumb rule, okay? So if one vector is multiplied to another vector, that will give you the other vector, but it has to go in a manner, okay? Because so let's say this is something like a x, something like a y and z. So it has to go x, y, z, right? So these are vectors. It has to, so x needs to be multiplied like this. So if you have a thumb like this, then I will show you video. So if you have this thumb, right? Let's say there's this vector is there, right? So you see this x and y. So let's say consider this first column is your x and the second column is your y. So this is how it's going, right? So x cross multiplied by y will give you z axis, which is positive, right? So you need to search like that. Okay. So let's consider first option, which is n cross a. So n is let's say x and o. If you multiply it, we will get a. Then there is something called a cross n. A cross n means z cross n. So if you z cross n something look like something like this, because z is, so it will give you y direction. So please look to that version, and then let's say B option is a cross o. So a cross o, which is something like let's say y to x, it's going from y to x. So for y to x, if you wrap your finger like that, okay, so you need to start from y and you need to end at x. Okay, your finger is going down, right? I think for the guys who will be watching this video by online, I will just give you. So it's going like this. So the third part, sorry, the B part, A cross O will give you minus Z, right? So Y cross X will give you minus Z. Okay. So it needs to be minus N, not N. Okay. So here the option will be B. Okay. So if anybody doesn't understand this, please uh, unmute yourself and tell me what part you haven't understand. If you have, then I will move on. And if you haven't, you can also type it in the chat box. Okay. So let's just start. So there's this question which was given in the assignment also. I will solve for this question, but the values has been changed here. So like let's say if a triangle, yeah, all question, but yeah. So if a triangle XY plane, triangle on the XY plane, let's say this is your XY plane, let's say this is your X, this is Y, and you have a triangle which is let's say yeah, P is yeah, this is the P, and this is C, and this is Z. Is rotated on a plane by 30 degree by keeping F, yeah, picking A. This is A point, and this is B point, and this is C point, right? So this point is fixed, and it is being rotated along Z axis, and it is rotated uh, on a plane by 30 degree clockwise. So so it's rotated like this clockwise, right? So when you use your right thumb rule, it's opposite to the diagrams because we are going from X to Y. Okay, please do remember when it's given XY plane, then it has to go from XY. So if you go from X to Y, it will move something like this, which is anti-clockwise, right? But it is saying anti-clockwise. So when anybody say clockwise, it is minus 30 degree. Okay, so theta is minus 30 degree. Okay, and they wanted to know what will be the coordinate of the triangle when it will be described in after rotation. Okay, so there was this formula which was given by professor that you have to when because you need to find the coordinate after rotation, right? So first you need to describe this rotation matrix. Okay, this rotation matrix will be described with respect to the fixed frame and with respect to a moving frame. With respect to so the rotation matrix after rotating 30 degree needs to be defined, which is rotated with respect to the so yeah, the moving frame is your 30 degree and the fixed frame is 0 degree, right? This we need to define, and it is written that it is being rotated. So the XY plane, so it has to be rotated along Z direction. Okay, and according to that formula, which was I think it's what was the formula called? So what you can do is like if you don't remember the formula, what you can do is there was this always the sessions are there. So you see, you can always download this part. Okay, so I've already down. So you can download this slides part. Okay, so I've already downloaded it. Where was it's this is a lecture 2 or lecture 3. I think it's a lecture 3. Lecture 3. So these are called coordinate transformation frames. Uh, so yeah, so these are fundamental rotation matrices. Okay, so what you can do is like nobody gives you. So please remember this basic three rotation formula. Okay, I'm not telling you to remember this big thing. Okay, you can get this thing, but please remember this rotation matrix. So basically, it's like this. Okay, so when you are rotating about let's say z-axis, this is what your formula is. Okay, sin theta cos theta minus sin theta 0 sin theta cos theta 0 0 0 1, right? So this is what you need to do. Okay, and so what I did was like uh yeah, small thing. Yeah. So let's say this is the P point, which is your updated point. Let's say, and this is your rotation point, and this is your last. This was the coordinate. Was present in the R, P, let's say Q. Q is your position. So Q is the position of this point. So let's say when you rotate stuff, your B will also rotate it with 30 degree. Okay. So let's say I am taking B value. Okay, B coordinate is 40, right? So 40, and the Z coordinate is 0. And I'm using that rotation about Z axis. And instead of theta, I'm giving theta equal to minus 30 degree. And when you do this transformation, you will get the new value of b, which is b dash, and this is b. Okay, and when you do this thing, you will get something like 2 root 3 and minus 2. Okay, and similarly you need to do with c also. A you don't need to do it because a is fixed. Okay, so for d also, what you need to do is the formula remain the same, the rotation matrix remain the same, but the coordinate will change now, which is 2 2. Okay, and you will get the thing, you will get the coordinate of c, the transform coordinate of c, which is b. So answer here will be b. Okay, and a similar problem has been given in, I think, in first assignment. So please utilize that part. Okay, and I think this is, and there's two more questions. So please bear with me for 2 minutes. So yeah, so there's this question: if R is a rotation matrix, 3 cos 3 rotation matrix, and R dash is its transpose. Okay, and P is, and P belong to, so this, where is P? Yeah, so P belongs to R3, which is like yeah, it is like a complex plane. The third order complex plane is a column vector, and T is a transformation matrix, which consists of rotation matrix. P is a prismatic. So P is a prismatic vector. P is a prismatic. I mean, the prismatic, not prismatic vector, but P is something like the position, how much dislocation the frame, the moving frame has been moved with respect to the fixed frame. And it's for 4 cross 4 homogeneous transform matrix. So yeah, so this is so they want to know what will be T transpose whole inverse. Okay, so you need to know what transform, you know already, right? Transformation matrix. Transformation matrix is already consists of this rotation matrix, and then there is something called translational matrix, rotation and translational matrix. It's not a matrix, it's a vector, which is P1, P2, P3. And so please remember this formula also. It's a inverse. When you do inverse, basically, if you, when you, I'm saying, when I'm doing, so if you want to go from A to B using a rotation matrix, okay, and when you want to go from B to A, you have to do R inverse. Okay, if you already know R, then you can do need to know. So when you go from B to A, you need to do the R inverse. Okay, this is a small thing which I want to tell you. So R inverse is basically something like that. So all this formula, all this rotation metrics are something called orthonormal, and they follow this principle. So R transpose is basically equal to R inverse. Okay. It's not R yeah. So what you need to do is you need to do R transpose or R inverse. All are the, so basically all are the same. Okay. So when you are inverse the rotation, you just need to do the inverse of RT or make the transpose. Okay. So let's just focus to this question, which is R transpose to the power minus 1. Oh, sorry, T transpose to the power minus 1. So you already know what T is. Okay. So this is T, and you already know T inverse. But so first you need to do T transpose. So how you will do? So T transpose will be something like this, and this is 0, 0, 0 basically, and basically this will be your T transpose, right? And when you do T inverse, you know how the T inverse formula work like. Just need to do R transpose here, and this will be something like R transpose, and yeah, so 0, 0, 0 remaining. So so this is T transpose inverse. This is how you will to write this. So this is a small formula which I have told you. Okay. Coming to the last question, if you have any question, please do ask me. I think I will check if there are any question. Where are those formula PPT, please? Uh, so all this formula, I think this formula, yeah. So Harni, the problem. So Professor has have briefly mentioned this formula. If you go to this, I think it's week second lecture. So Professor Sukavamana haven't specifically mentioned this formula, but there was this question, there was this proof he was solving, and there he used this uh, there he used briefly this formula. Okay, so if you look closely, go to those lecture, you will find this proof. You will find this formula. Okay, so this is a simple formula. You can. So I will also share this slides. Okay, so please don't worry. But yeah, you need to remember this formula. Okay. And coming to, I think, yeah, I think there was one more question, but I think I haven't formulated that. Okay, okay. That's it with the today's session. I think I've already taken 1 hour, but yeah. So today's session is bit on the introductory side. From the next session onwards, I will try to stick to the questions only. I will not give you some introduction thing. Okay, and I will solve some problems. I think the week two is all related to week two. I think if you see week two, there are much more mathematical problems are there. Okay, so I will solve two, three problems so that you get to know like how to solve those problems, and you will also get those get this week solutions also. So please remember the due date is 5th of February. Okay, so please start submitting the solution. Not submitting, just need to point it out and you need to submit it. Okay, submit your answers. Okay, and of course, I mean, you can submit this answer. So you have so like if you submit this thing, something like so like if I'm submitting, let's say I have not submitted the all answer. Thank you for taking the week. So you can again choose and submit. So if you've already submitted, and if you like forgot, like okay, there's one question which I left, you can again submit this thing. Okay, there's no okay, and until so this you can do this before this due date. Okay, after let's say third or after let's say 6th of February, you can't able to do it because it will be automatically submitted. Okay, so please so that uh, it so that so this give you convenience so that you can do some questions on some day and some questions like after some time. Okay, so it give you it give you that convenience. Okay, so please remember that. Okay, and I think anything to say, anything any questions. The books part, I think you can choose any books. I think I don't know if Professor Suvakama has said anything about the books. But there are some books which I can give me a sec. I think I have some. Mm. There was this book by John J. Craig. Okay, so this was the universal book for robotics. Okay, so you can actually type this in Google and you can easily get the soft copy. I think it's freely available. I think what you just need to do is uh, just need to type this. You can easily get the PDF. So there are multiple introduction to mechanics. Okay. Okay. What I think. So this, so the soft copy is available. Okay. Okay, and You can also, there are some problems in there, so you can easily there are some solved problems is also there, so you can solve that also if you want to. Okay. And, any more questions related to the course and anything else? Yeah, nothing. Yeah, I forgot that. Yeah, so Shashank, I've already told you the Craig is the one book which you should refer. Okay, I don't know if there is any Indian author book. There was one. I think there was the book by Asitawa Ghoshal, but these books, I think I won't prefer that because the Professor Ghoshal has gone too deep into the mathematics part. If you are interested, you can uh, go through it. But so Craig, the good thing about Craig is like they have not gone too deep into the mathematics part. Okay, they have gone it, but uh, basically they have not gone too deep. And the solution, and there are some questions, there are some solved solutions are also there. Okay, which you can easily uh, get to like you can easily, I mean, you can easily solve these problems also. So please. And the good thing is like some of the unsolved question there is already a solution available. Okay, so please go through this book. I mean, I would prefer to go, and if you have anything, any some books, you can easily, if you know any book, you can free to share here also. Okay, okay. Okay. I think yeah, so that's it for today's session. So I will meet you next week, Monday, 7 p.m. 7 p.m. and I will so I will take every week 1 hour class. And so please guys, there is all there I think there is an exam also. Okay, so it's a 8 week course. After 8 week you need to register for this NPTEL exam if you want to. Uh, there's no pressure. Okay. And yeah, I think yeah, anything else? I think yeah, so I will so we will meet next week, guys. So till then, bye bye. I will stop this meeting. Okay. Yeah, you can leave if you want. I will stay there. Somebody has a book on this subject. I've told you, Vivek, Vivek, you can leave the meeting. The session is over. If anybody have any problem, you can. Okay. I will type that title. So the book name is Craig, right? Mm, Craig, Craig, John J. Craig, John J. Craig Solution, Introduction to Robotics. Yeah, so yeah, okay, okay, okay. Bye bye, guys.